Okay, so in 4.4, we're simplifying complex rational expressions, and I hate the name of this because when you think complex, you think, oh, that's got to be really difficult, and these look really crazy, but if you treat them kind of in a certain way, it won't be so hard to be able to do them, because it's kind of like you're doing sometimes 2 or 3 problems in one, and that's why they look a little bit crazy. So we're going to take the stuff that you know from multiplying and dividing your rational expressions, and also the adding and subtracting rational expressions, and now we're kind of putting both of those together on this. Okay? So there's 2 different methods that you can use to do this, and I would say it would be good to just get in the habit, like once we kind of go through both, maybe just see which way works better for your brain, and then maybe try and stick with it, because otherwise it's easy to get those mixed up in your head. Okay? So, all right, so let's look at this first one here. So on this one, we're going to kind of treat these as 2 separate problems. So do you see how on the top, so I've got like a fraction within a fraction, right? And that's why these look so crazy. So on the top, I just have one fraction though, right? R squared minus 4 all over 4. However, on the bottom, I have 2 different parts, so I need to get that as one fraction. So we're going to follow what we did in 4.3 to help us do that. So let's look at just the denominator part. So, the denominator of this whole thing, right? The 1 plus 2 over r. And I'm going to put a 1 underneath that 1 just to remind us that our denominator right now is 1 there, right? And on my other denominator, it's an r. So I can see, all right, I need to multiply this one by r, so I have an r on the bottom like the other one is. And so if I do that to the bottom, I also need to do that to the top. Okay, so when I do that, so I'm just looking at this bottom one here. I'm kind of treating them as 2 separate problems, okay? So r times 1 is r, and then plus 2. And then on the bottom, I found that common denominator was r, so that's what I put on the bottom here. They both were r, so that's what I'm going to have it as. Okay, now let's look at, I'm going to put this to kind of separate it out, and then I'm going to use a different color here on the top. Okay, so we can see on this, we already have it written as 1 fraction. However, that r squared minus 4 can factor. So let's go ahead and do that. So 4 is going to stay as my denominator there, but my numerator is going to be, it's a difference of squares, so I got r plus 2 times r minus 2. Okay, so now what I have is just a fraction divided by another fraction. Right? And sometimes when students look at that, it just makes your head kind of spin, right? But let's just remember back with just division of fractions, right? If I had 3/4 divided by 5/16, how do I do this division? Do you remember? Got to keep that first fraction the same, change my division to multiplication, and then flip, like do the reciprocal of that second one, right? So I've got 16 over 5. And now I just want to, I can see that, oh, I've got some common factors I can divide out. 4 divides into 4 once, and into 16 4 times. And then I can just multiply straight across to get my answer. So 3 times 4 is 12, and then 1 times 5 is 5. And so 12/5 is my answer. So the part that I want to make sure you see here is that when I have division, I keep the first fraction, change it from division to multiplication, and then flip that second fraction. Okay, so we could write this out kind of as a division problem. And if that's easier for your brain, then do it that way. So what I mean by that is I can do r plus 2 times r minus 2 all over 4, right? And then divided by that second part, which is r plus 2 over r. Okay, so again, just like we did here, keep the first fraction just like it is. All right, so I'm going to change this. I'm going to have, this is going to be r plus 2 times r minus 2 over 4. And then instead of having division now, I'm going to put multiplication, and I'm going to flip, right, that second fraction. So now I have r on the top and r plus 2 on the bottom. And now we want to look and see if there's any common factors we can divide out, kind of like I did with these. I saw 4 and 16 had a common factor. And so on this, I'm looking any factor on the top with any factor on the bottom. Well, I see I have an r plus 2 on the bottom and an r plus 2 on the top. So those are going to divide out. Okay, and there's nothing else. There's just a 4 left down there. And be really careful because, again, this 2 and that 4, those cannot divide out. The r minus 2, they are connected tightly together. They're like best friends. You cannot separate them. Okay, and so that has to move as one whole thing. So what we're left with is just, on the top is r times r minus 2 all over 4. And that would be your answer. Now you can distribute that r through and have r squared minus 2r, and it will still, it will count it right either way. But I'll encourage you to leave things in factored form, just because with what we're going to be doing next with these, it's going to make it a lot easier if they're already factored. Because if you multiply it back through, then you're going to end up having to undo that process. So we'll try and leave them in factored form. Just get in that habit. Okay, any questions I can answer on that one? I hope using those colors kind of help so you can see it's just a fraction divided by a fraction.
It does help, but it's very complex.
It does. It does. So take a deep breath, right? And try and just look at part of it at a time, and just be like, okay, I'm going to focus on this one, right? Okay, let's see. So let's try this one. So we'll do it the same method, and then we'll try doing the second method so you can see which way you like better. All right, so again, we're just looking at the top or the bottom. So right now, I'm just going to look at the top. And I'm going to put, actually maybe I'll just like a 1 underneath that and a 1 underneath that. It just helps remind you that you've got to get that denominator looking the same. So that's why I do that. Okay, so I can see that k, I'm just looking at my numerator right now, k is going to be my least common denominator. So I need to multiply the bottom by k, which means I need to multiply the top by k. All right, and so then when I write out my fraction over here, k is my common denominator, so it stays down here. And then on the top, I have 2 minus 1 times k, which is just k, so 2 minus k. right, now let's go to the denominator of the whole fraction there. All right, so similarly down here, you can see, all right, k is going to be my denominator as well down here. So I'm going to multiply that by k, multiply this by k. So k is my denominator, and then on the top I have 2 plus k. Okay, and now that I have one fraction on the top, one fraction on the bottom, I can treat this like a division problem. So you can write it out like division like this, or the other way that you can do this is kind of look at it and say, okay, I'm going to do times the reciprocal of the bottom one. So I'm taking this in blue, putting k on the top, and 2 plus k on the bottom. And then now I'm just going to kind of cross out this because I moved it up here. So now it's connected by multiplication because I flipped it. Right? That bottom fraction is kind of like my second fraction. That's the one I need to flip. And then I want to see what there is that I can divide out. Well, this k and this k can divide out. Anything else that can divide out?
Well, your 2's can divide out, right? No, they can't. Because one's multiplied, because one's minus and one's plus, right? So they can't.
Yeah, they'd have to be connected by multiplication, right, in order to divide those out. But isn't it tempting? Like you totally want to divide those out. You totally want to divide the k's out, but you can't do that. So yeah, you're exactly right. That is all we can do. So that is our answer. So, because remember, when we're dividing things out, the opposite of dividing is multiplication. So things have to be connected by multiplication in order to divide out. They can't be connected by subtract or add, because the opposite of add is not divide. The opposite of subtract is not divide. Right? So we've got to just be really cautious with that. Okay, so that would be done. So the second method, instead of working the two problems kind of separately, you're going to actually look at both denominators and get an LCD of both of them. So that 8p and that 4. So I'm looking at both of the denominators there, and I'm trying to find the LCD of those. What do you think that would be? Well, we know a 4 is going to be there, right? Because this has 4. What times 4 is 8?
2p.
2, yep. So we need a 2 there, and we also need a p here. All right, so 8p, it is a multiply sign. So 8p is my LCD. All right. So I don't need to multiply this by anything because it already has everything. However, the 4, what do I need to multiply it by? 2.
2 and a p, right?
Yeah, 2 and a p. And so if I do that on the bottom, I also need to do that on this one. Okay, and I'm going to put this, just sometimes having this bigger like kind of fraction bar here is helpful, just to kind of keep those guys separated and kind of think about these as the separate parts. Okay, so my numerator, there's nothing, the numerator of the big whole fraction, that whole thing there. I'll say the top fraction. Maybe that will be a better way to say what I'm trying to do here. So that's going to stay as 2p minus 5 over 8p. All right. And now, let's see, I'm going to have this, and again, you could, change it into a division problem if you wanted to, with the divide sign. So that's going to mean I need to distribute this 2p to everybody. So that's going to be, whoops, not 2, Where's my, let's see here. So 2 times p and 7 times p is going to give me 14p squared. That's what I meant to write here. And then 2p times 1 is just 2p, so plus 2p. And now it's all over 8p. All right, so I can see that I've got both of these denominators the same. So I'm going to keep that first one, that first fraction, 2p minus 5 over 8p. Change the divide to multiply, and do what with that second fraction?
Flip it.
Yeah, flip it. Okay, and even though like I multiplied these through, it may have been, you know, easier to leave them separate, because there is something that we can do there to divide, or there might be something we can do to divide out. I mean, I'm going to leave it for right now, and then we'll kind of see. Whoops, sorry. Where's that supposed to go? Not there. It's supposed to go on the bottom. Okay, so 8p goes on the top, and then 14p squared plus 2p is on the bottom. All right, now look at what happens here. The reason why doing it the second method is nice is because we'll always have the denominator of our first fraction will always divide out with the numerator of our second fraction. Is if we make those both, you know, both of the denominators with a common, you know, their least common denominator. And now when I'm looking at this, right, I've got 2p minus 5 on the top. There's no way to factor this to get 2p minus 5, but you'd want to look at that and see. So what we end up with is just 2p minus 5 over 14p squared plus 2p. And then that would be your answer. Okay, and if you left it in this factored form over there, it would still accept it. Okay, so sometimes instead of multiplying that through, keeping it factored could be helpful, just so you can make sure there's nothing else. All right, so do you see the difference between these? It's a little bit subtle, but here we're trying to get an LCD of both of the denominators, where the first method, we treat these as two separate problems. And then once we get those to be, you know, a fraction over a fraction, now I can flip that second one. Okay. All right, let's do one more here so we can see. Let's do this one because we haven't done one quite like this yet. All right, so at top I've got 1 over a minus 1 over b, and then on the bottom I've got 1 over a squared minus 1 over b squared. So again, remember, it's on this second method, it wants us to find the LCD of both of the denominators. Okay, so let's focus on this first one. So what would our LCD be of this top part of it?
AB on each one?
Yeah, so AB, A times B is going to be part of that, right? Okay, now what about on the bottom? So do you see this? There's already one A there. But this one, remember, A squared means A times A. So I need another A here. So I'm going to change that to an A squared. I need an A times A. And then the B's, right, I have one of them here, but the bottom there has two, so I need to make sure that I change that. So my LCD is what I have here, that A squared and B squared. That is my LCD. Okay. And so now on this, right, I'm trying to get those denominators to become that. So I want it to look like a squared b squared. And so I'm looking here and I'm saying, okay, what do I need to multiply this a by to get it to be a squared b squared?
Are you going to times it by itself?
Close, right? So it has one of the a's, but it needs another a to multiply by it, and it needs both of those b's. All right, so on that numerator here, so let me extend this out a little bit so you can see. So we need to multiply that top part by the b times a. Oops. All right, so that they, because that was the part that it was missing. And then on the denominator that just has b, let's see, I'll keep it green. So this one, all right, has one of the b's, but I need another b, and I need both of my a's. So on the top here, I need to multiply this by b times a times a. All right, so do you see on the bottoms of both of these now, I do have, I've got a squared, b squared, a squared, b squared. I just have them, written out so we can see each of the different factors. So on the top here, I've got a and then times b squared. And then I need to minus, I've got a squared times b, because it's just multiplied by 1, so that's not really changing anything else there. Okay, so that's how my whole, that's just that one, part up there. So, but remember, we already found the LCD for the bottom as well, because we said, all right, yep, that's going to be that same a squared b squared. A squared times b squared. And let me put my big division bar here in between so we can remember. That's our big fraction there. Okay, so let's take a look here and see what it is missing. So I have an a squared on the bottom. What do I need on that part? Oops, that's what I meant to do. So I've got a squared. What does it need to be able to look like a squared b squared? It's missing that b squared part. So if I'm going to multiply the bottom by b squared, I need to multiply the top by b squared. And similar over here, it has the b squared, but it needs an a squared, so let's multiply that by a squared on the top and on the bottom. Okay, so then my numerator is b squared times 1, which is just b squared, minus 1 times a squared, which is just a squared, minus a squared. Okay, so I know that's a lot. Are you totally confused, or are there questions? I know, there's a lot, right? I get it. And it does take some practice, for sure. But when we get it to this point, right, then we can say, okay, I'm going to flip and multiply and see what I end up with here. And I want to be able to see if there's, anything that can divide out as well. So what I'm going to do before, well, it doesn't matter which order I do it in. Maybe I'll do the flipping of it now so I don't forget to do that. All right, so I've got that AB squared minus A squared B over A squared B squared. And then instead of being, this is division, so we're going to flip and multiply that. So I've got to have A squared B squared on the top, and then B squared minus A squared on the bottom. So again, the reason why we like this method is because that whole denominator and that whole numerator will divide out if I use this method. Okay. And then we want to see what we can do to factor any of the remaining stuff there. So let's see, I'm going to go to black here. So there's greatest common factors that could come out of this. All right, so I can see they both have an A and they both have a B. So AB can come out, and when I do that, I'm left with B minus A. Okay. Then on the bottom, I have B squared minus A squared. Well, that's a difference of squares. So I've got B plus A times B minus A. And then I see, oh yeah, there is a common factor that I can divide out, which is this B minus A. And so then my answer is just AB on the top, B plus A on the bottom. That is the answer. Can you think of any parts I can clarify better for you? I want to make sure you're understanding this, and I know it's a lot to take in.
I think that I'm gonna have to do it,
Mm-hmm.
and then I know it's probably I'll be finding some parts that are hard, but I'll make sure that I watch the video.
Yeah. Yeah.
And I should be okay.
Yeah, I think you will. It just is going to take some practice is really all it comes down to on some of these. So,
Yes.
all right.